Hello, scholars. Today we are going to be learning how to draw Lewis structures. These are based on those Lewis symbols that we learned in our last unit. So I'm going to show you how to do this. So let's get started. First thing we want to look at are components of the model. There is a lot going on this slide because normally we do this as like a group thing in class, but um, let's talk about the components of the model. You don't have to write all this down, but the main things, what are the unpaired electrons? Electrons, can you identify them in the diagram? Do they form bond? So yes, the unpaired electrons, when you draw your Lewis symbol, let me just like kind of go over these. So if we were to draw these as Lewis symbols, you would see your hydrogen with one dot, right? Because they have one valence electron. And then you would see your oxygen with 6 dots. And remember, it doesn't really matter what side you put the paired and the unpaired electrons on, as long as you have 2 electrons that are paired and 2 electrons that are unpaired. Um, because remember we put one on each side, 2, 3, 4, before we double up. And then once we have one on each side, then we can double those up. So the first question asks, what are unpaired electrons? And can you identify them in the diagram? So I'm going to just use my orange highlighter here to highlight this. Here we go. So let's go over this. So the unpaired electrons here are, well, these ones, the ones that just don't have a partner yet. We're going to ignore the lines right now because we're supposed to add those later. And the question is, do they form bonds? And no, they do not form bonds. They do not form bonds. No, that's wrong. I lied. Yes, they do form bonds because they are lonely. They are sad and lonely and they want a partner. They just want their like boyfriend or girlfriend electron. And so they're going to bond. They're going to form bonds. And then what about the paired electrons? Let me pick a different color. Let's do this like purple. Let's do purple. What are paired electrons? Can you identify them in the diagram and do they form bonds? So paired electrons, these guys are our paired electrons. See how they're already kind of doubled up? So they already have a partner. So these ones are the ones that are not going to form bonds. Then the third question asks, what do the lines in between the atoms represent? So let's do like a green. So what do the lines in between the atoms represent? So that would be talking about these lines. And those are bonds, right? We see it right there. So the lines are bonds. It's a bond. And then how many electrons does a line represent? So if we look back at that, the line represents 2 electrons. 1 electron here, 1 electron here. So that's going to be 2 electrons, one coming from each that's being shared. And we saw this in our gizmo last week. Oh no! So what you should write down on this page, on your notes, is probably this stuff. So we want to identify the components of the model. This goes under the components of the model section of your notes pages. So Lewis structures have element symbols. They have bonds that are represented by lines, and that's 2 electrons. And then they have what are called lone pairs, and those are the ones that were already paired up before we started to connect the atoms together with covalent bonds. So this info down here, this is our important stuff right here. It shows the bonds between atoms, it shows the lone pairs, it helps model the structure of covalent compounds, but we can't use these for ionic compounds because these lines here represent shared electrons, and as we know from previous lessons, covalent compounds do not share electrons. They just take the electron and dip. So that's how we do that. So let's extend this. Now, how do we draw these? How do we get to that point? Let's do teal because it's Delago. So the first thing I like to do is we want to use Lewis symbols, and that's going to tell us how many bonds each atom is going to form. So I have CH2O, so I have a carbon, a hydrogen, and an oxygen. So I'm going to draw Lewis symbols for those. I'm going to draw C, an H, and an O. So if we look at our periodic table, we know that carbon has 4 valence electrons because it's in group 14 or 4a. We know hydrogen has 1 valence electron because it's in group 1. And we know that oxygen has 6 valence electrons because it's in group 16 or group 6a. So for me to draw these Lewis symbols, remember think of your little symbol has 4 sides. So for each element, I'm going to draw 1 dot on each of the 4 sides representing a valence electron. And since carbon only has 4, then we're done with carbons. And then we're going to move on to hydrogen. Hydrogen gets 1 dot. Remember, it does not matter what side you put the dots on, as long as you put 1 on each side before you pair them. And then for oxygen, I have 6 valence electrons. So I'm going to have 1, 2, 3, 4, 5, 6. I like to go clockwise, but like I said, you don't have to. And then how many bonds is that going to make? So for carbon, it's got 4. Oh, that doesn't show up very well at all, does it? For carbon, it's got 4. I don't think any of those colors are going to show up well. What if I do white? Will that work? That doesn't even work at all. What the heck? All right, so what is happening? There we go. Well, now I'm not getting anything. Oh, yeah, it is showing up. It's just not very bright. All right, let's go back to red. Okay, so for carbon, I have 1, 2, 3, 4. I'll just use my laser pointer. 1, 2, 3, 4 unpaired electrons, which means that's going to be 4 bonds. For oxygen, I got 1, 2 unpaired electrons, so that's going to be 2 bonds. And then for hydrogen, I only have that 1 unpaired valence electron. Remember, a hydrogen has a full valence shell with only 2 electrons, so you don't have to do much there. So I'm gonna, that's gonna make 1 bond. Okay, awesome. So now we know that. Let's move on. We want to start by putting the atom that makes the most bonds in the center. So if I look back here, carbon makes the most. It makes 4 bonds, so it's going to make the most bonds. So let me draw my carbon with its 4 little dots. And drawing Lewis structures is kind of like solving a puzzle. It's really fun. All right, so now I've got my element with the most bonds in the center. I'm going to copy this so I can just put it on my next slide. All right. And then we're going to add the non-hydrogen atoms. That's step 3. Oh, right. Paste image. We can just paste. Okay, so now I've got my carbon. I'm going to add non-hydrogen atoms. So if I recall back here, I have oxygen, or I have hydrogen, so I'm going to add the oxygen next because it's not a hydrogen. Oxygen. Okay, so here's my oxygen. It's got its 6 valence electrons. Okay, so and then we're gonna just go ahead and bond those together. Hey, you guys are attached now. All right, and then what's my next step? I'm gonna copy this again. Copy. Okay, and now my next step is I'm gonna now add the hydrogen atoms. So I have 2 hydrogen atoms, see here, CH2. So I'm gonna add those 2 hydrogen atoms. So I'm just gonna do 1 here and 1 here. Cool, but I have a problem. So my problem is I still have single electrons. We want everyone to be partnered up here. So I need to figure out what to do with those. And sometimes you'll have leftovers if you follow these rules, and sometimes you won't. If you don't, you're done. But if you do, then we get to start double and triple bonding. So now what we're going to do, so I've got this situation going on. I have a lonely electron here, and in this other element that's connected to it, I also have a lonely electron. So what I can do is I can just pair these guys up. So this electron can move over there. Remember, Lewis structures are just a model, so you can move the electrons around like that. And then those two can now partner up, and now I have a double bond. So again, you may or may not have double bonds in your structures. But if you follow steps 1 through 3, nope, steps 1 through 4, and you still have unpaired electrons, that means you probably need to do a double or a triple bond. So that is Lewis structures. Yay! Now we're going to do some practice problems. So move on in your Pear Deck to do some practice problems.